on the back of lacrosse helmets that read, "Lacrosse is dangerous. Use this helmet at your own risk. You risk severe brain, head, and neck injuries that cause paralysis or death." But still, women's lacrosse players are mandated to wear goggles. And in this project, we look to answer the question, should field players wear helmets?
In women's lacrosse, there are many different scenarios where players are involved with contact to the head. Cases such as getting hit with a stick on a follow-through of opponent's shot, getting stick checked to the head, or even getting shot with the ball unintentionally. In all these situations, field players are put into an environment where they are vulnerable to head injuries such as concussions, which then begs the question, should field players in women's lacrosse wear helmets?
U.S. Lacrosse put out a performance standard in 2017 called the ASTM standard that women's lacrosse headgear has to meet. The purpose of creating this new rule within women's lacrosse was to reduce the force of impact from a lacrosse ball or stick. As stated in the standard, the equipment has to be able to pass 3 tests: the shock absorption test, the ball impact absorption test, and the deformation test. Because there is no mandate that every player must wear a helmet, U.S. Lacrosse made clear that the soft helmets must be safe so that no harm is caused to the players who don't wear helmets. This is stated in the standard saying, any optional devices excepting eye protection for the headgear shall be designed so that they are unlikely to cause any injury to the wearer or other participants during contact. Unlike men's lacrosse, where it is a rule that all players must wear the hard helmets.
So to relate this to some physics concepts, when a player's head comes in contact with a stick or ball, that is considered a collision, which can be defined as a change in the velocity caused by forces when objects hit each other. Collisions produce different types of energy, and one being kinetic energy, which can be defined as energy a body possesses by virtue of being in motion. In our example, we look to evaluate kinetic energy using these 2 equations, Ke equals 1/2 mv squared and Ke equals distance times force. And the units for those 2 equations are joules and newtons. Impulse is a factor in collisions that relates to the use of helmets. In this equation, an increase of change in time helps reduce force, which is essentially the purpose of wearing a helmet.
The role of helmets is to reduce the total force applied when contact is made to the head. Helmets act similar to a cushion where they decelerate the motion of the object and therefore prolong the time of contact with the helmet. So as the contact time between the object and the helmet increases, the total force applied to the head reduces due to the equation kinetic energy equals force times time.
Here's more of a visual representation of what I was talking about. So using the impulse equals force times time equation, we saw data where time was shortened between the head and the object, and with that the force skyrocketed up without using a helmet. And with a helmet, the time was actually prolonged, but with that the force was reduced, and therefore lowering head injuries to players.
In a study published in the Journal of Biomechanics, conducted by Joseph Crisco, Michael Rainbow, and Eileen Wang, lacrosse shot speeds were studied due to the dramatic changes in the lacrosse stick. Figure 5 depicts recorded speeds for men and women for both the ball and the stick tip. On average, the stick tip speed for females was 45 miles per hour. First, calculate the kinetic energy of the stick. Then, use the kinetic energy to find the force. According to head injury expert and neuropsychologist at the University of Denver, Kim Jorgen says that most concussions deliver 95 Gs or 1,800 to 2,000 newtons to the human body upon impact. Finally, compare the force of the stick to the force needed to cause a concussion.
Oh. Ow.
According to Figure 5, on average, the ball speed was also 45 miles per hour. Following the same method of the force of the stick, we calculated the force of the ball. According to Figure 5, men's ball shot speeds average around 75 miles per hour, while stick tip speed averages around 65 miles per hour. The force of the men's stick was well over the concussion force threshold, while the force of the ball was just under. In a game where stick swinging and checking is prominent, helmets are very necessary. In addition, both calculated forces are averages, meaning the force of the ball can exceed the concussion force threshold. Should women's lacrosse players wear helmets? Well, according to the calculations, the force of both the ball and the stick are not enough to cause concussions. Players should still employ proper safety techniques. Although rules are set in place to ensure the safety of players, players are subject to a plethora of contact, which can result in serious injury. Additionally, the calculations are based on averages, which does not account for extenuating circumstances or outliers. So, should women's lacrosse players wear helmets? The answer is indefinite and is based on an individual platform.